generating a mesh in Cubit, there are often cases that even with web cutting, setting sources and targets, applying vertex types, and even smoothing, that an acceptable mesh quality just cannot be achieved. One option is to insert one or more layers of elements at the surfaces where the poor element quality is occurring. This technique is called pillowing. This brief tutorial demonstrates the use of the pillowing tool in Cubit for improving mesh quality. We'll begin by demonstrating the pillowing command on a simple mesh of a brick. Let's start by pillowing one of the surfaces of this brick. To do so, in the command panel, select Mode Mesh, Entity Surface, and then Action Refinement. In the drop-down, you'll see three options. Select the pillowing option. For demo purposes, I'm just going to select the top surface. For this case, I'm going to make sure the No Smoothing option is checked, and then I'll hit the Apply button. Notice what happens here. An entire layer of hexes is inserted right next to surface 5. This is done by splitting each hex in the top layer into two. Next, we'll select two surfaces as input to the pillowing command. Notice the result is a continuous layer of hexes that wraps around the corner between the two surfaces. Let's look at an example now of where this pillowing technique could help improve mesh quality. Let's reset our Cubit session, and if you're following along with the provided example files, let's go ahead and open example20_1.cub. Just from visual inspection, we can see that the elements at this location seem to be somewhat suspect. This can actually be quite common whenever we have to force a mapped mesh into a circular region. Let's go ahead and examine the mesh quality now. Just as a reminder, we can get to mesh quality by going to Mode Mesh, Entity Volume, and then Action Quality. We'll select the volume, use the default shape metric, and then use the option to display a graphical summary. And we'll hit the Apply button to display the mesh quality for this volume. Notice where the poor quality elements are mostly concentrated, and the shape metric of about 0.1 for the worst quality elements. We'll try using pillowing to help improve this quality. Hit the refresh icon in the toolbars at the top to redisplay the object. And then we'll navigate to the Surface Pillow panel. Notice the almost 180-degree angle between two faces of the same hex. By using pillowing, we can push that 180-degree angle into the interior of the volume, where smoothing can take over to help improve the mesh quality. Go ahead and select these two surfaces to pillow. This time, let's leave the smoothing on, and then hit the Apply button. Looking at the output window, we immediately see a warning was produced for mesh quality. Although the smoothing option was on when we did our pillowing, sometimes it may not be sufficient to achieve the quality that we need. As a result, we sometimes need to manually apply smoothing following the pillowing operation. Smoothing provides a way to improve mesh quality without changing the element connectivities by simply moving node locations. Looking back at our first pillowing example, I apply smoothing to the surfaces. Notice that the nodes on the curves do not move. Smoothing the nodes on a surface will not change the node locations on its surrounding curves. Likewise, applying smoothing to a volume will only change the interior node locations and leave the surface and curve node locations untouched. For this reason, we'll perform smoothing progressively, starting with curves, then surfaces, and finally volumes. Since we're already in the Mode Mesh area of the command panels, click on the Entity Curve button, and then the Action Smooth button. In this case, let's use the default Laplacian smoothing algorithm, and then enter all for the curve IDs. That can be done by right-clicking on the Pick widget, and then choosing Select All. Hit the Apply button now to perform the smoothing operation on the curves. Next, we'll navigate to the Surface Smoothing panel. That will be in Entity Surface and Action Smooth on the command panels. I like the mean ratio smoothing algorithm for surfaces. It's an optimization-based technique that does a good job in cases such as these. Once again, we'll enter all in the Surface IDs pick widget, and then hit the Apply button. Next, we'll do the same thing for volumes. Navigate to Entity Volume and Action Smooth. Once again, we'll use the mean ratio smoothing algorithm, and we'll choose our one volume to smooth. And finally, hitting the Apply button will perform the smoothing operation on the volume nodes. Let's take a closer look now at our area of concern. Notice that by inserting the pillow layer, we were able to move the poor quality element towards the interior, where smoothing was able to improve the mesh quality. We can verify that the mesh is acceptable by displaying the mesh quality. First, we'll navigate to the Volume Mesh Quality panel, and using the same settings, we'll hit the Apply button to view the mesh quality. Notice that our minimum shape metric now is about 0.48, which should be acceptable in most cases for analysis. Now that we've seen a couple of examples using pillowing, let's dive a little deeper into what the pillowing operation is actually doing. The image on the left shows a hex mesh that is about to be pillowed. The hexes that are colored yellow are what we call the shrink set. The pillowing operation consists of shrinking the elements in the shrink set away from its neighbors, as shown in the middle figure, and then forming a layer of hexes or pillow between the shrink set hexes and its neighbors. Here's a simple 2D example to illustrate. I'll select a set of 9 hexes to act as my shrink set, and then perform the pillow operation. Notice that an unbroken ring of hexes is formed completely surrounding my original shrink set. We can alter this result by introducing what we call a through surface. Just by adding this additional argument to the pillow command, we can control where the pillow layer exits the volume. In this case, our through surface is the surface on the right. So for our initial example, where pillowing inserted a single layer at the top surface, Cubit internally selected all of the hexes as the shrink set, and then designated all but the top surface as through surfaces. Likewise, when we selected 2 surfaces for the pillow command, the through surfaces were automatically designated. This should help us better understand the command line syntax for the pillow command. Let's take a closer look at the output window after we generated our initial pillow on the brick model. Notice the command syntax where all hexes are designated, and all surfaces are designated as through surfaces, except for surface 5. Let's take a look at one more example of the pillow technique where we can take advantage of this powerful command line syntax. Starting from a new session of Cubit, let's go ahead and open a new Cubit file called example20_2.cub. For illustration purposes, once again, this model has already been meshed. Let's turn on the transparency mode and turn off the display of the elements. This helps us see better what's happening with this geometry. In order to sweep this geometry, on the cylinder, we had to apply source and targets at these surfaces. The resulting mesh quality, however, is marginal. Let's take a quick look at the mesh quality. In this case, I'm going to use the command line to do so. This command will display the scaled Jacobian metric for all of the elements in this model. Notice the lowest quality element metric is at the corners of our cylinder's mapped mesh. Since it's our cylinder that appears to be causing us our problems, I'm going to take a closer look at that by drawing the volume. To improve our mesh quality, we're going to insert a pillow using the elements of this volume as our shrink set. I'll also take note of these surface IDs since we'll be using those in our pillow command. In addition to our elements in the cylinder volume, we also have poor quality in its adjacent volume. To illustrate that, let me draw all of the hex elements immediately adjacent to surface 31. To help our mesh quality, we'd actually like to include these elements in our shrink set when we perform the pillow command. To prepare for the pillowing command, we'll use Cubit's grouping utility to assemble the hexes in our shrink set. To create a group, let's use the command panel we'll go to Mode Geometry, Entity Group, and Action Manage Groups. To create our group, let's first give it a name. Let's call our group Shrink_Set. Let's put the hexes immediately adjacent surface 31 into our group. To do that, first make sure the word hex is selected in the drop-down, and then we'll type the syntax to select all hexes adjacent to surface 31. Hitting the Apply button now will create our new ShrinkSet group. I can verify the contents of my ShrinkSet group by typing the command draw shrink_set. So far, that looks like what we want. Let's now add all of the hexes in the cylinder volume to our ShrinkSet. We'll use the same panel to do that, but enter the syntax in volume 5 in the field, and hit the Apply button to add to the group. Let's verify one more time that we have the elements that we want in our ShrinkSet by drawing the ShrinkSet group. Now that we're satisfied with the set of elements in our ShrinkSet, now we can go ahead and issue the pillow command. First I'll redisplay the model. Starting with the word pillow, we then specify the set of hexes in our ShrinkSet. In our case, we use the hexes in our group called Shrink_Set. We also want to specify a through surface. Since we'll want the pillow layer to actually exit the volume, we'll use surface 32 as our through surface. And we hit the return to execute the command. As you can see, a layer was inserted around the boundary of the cylinder. And from here we'll use the smoothers to improve the quality even further. Since the commands for smoothing are simple, I'll go ahead and issue those directly at the command line. First we smooth all curves in the model, then smooth all surfaces in the model. And finally, since smoothing volumes is sometimes more critical, I'll go ahead and use the command panel for that. You'll need to choose Mode Mesh, Entity Volume, and then Action Smoothing. This time I'll use the condition number smoother, and then enter all for my volume IDs. And hitting the Apply button will execute the condition number smoother. Our final step is to verify that we have indeed improved our mesh quality. Once again, I'll issue the quality command from the command line. As you can see, our lowest quality element now is about 0.39, which should be sufficient for analysis. I hope you've enjoyed this tutorial on using pillowing to improve mesh quality in Cubit. Thanks for watching.